Hello, everybody. This is our weekly paper by Beatrice Diaz-Pauli and colleagues from Norway studying artificial selection on size in fish and its effect on life history and personality. So this paper again on fisheries-induced selection on fish. So the idea again is that commercial or recreational fishing selectively removes certain types of fish individuals from a population and therefore is artificial selection against those types. And this can cause evolution in the population. And the idea is that this evolution will make the fish more adapted to the fishing, but less adapted to the natural environment. And if it's less adapted to the natural environment, then we will see a lower mean fitness in the natural environment, higher mortality rates, lower reproductive rates, and lower productivity of the fish population. And the end result is that the fishery is no longer sustainable, or at least that's the worry. So, how does life history enter into this scenario? Well, the prediction is that if you selectively take large fish, then you are selecting against individuals with a particular life history. You're selecting against K-selected individuals or slow life history individuals. Larger fish generally mature later, at a larger size, and have a longer lifespan. So harvest tends to shift the population towards a fast or R-selected life history. And there are many papers, review papers including, that show that this is a general trend in many harvested species. But the situation is a bit more complicated than this, since the two sexes often have different strategies. They might evolve differently as a result of fisheries harvest. Females might be more affected than males by harvest. For example, if the natural environment tends to favor K selection in females and R selection in males to some extent. Also, fish often have a personality, and that personality is related to their life history syndrome. More K-selected individuals tend to be more shy or timid, and more R-selected individuals in species tend to be more bold and risk-taking. And fishing harvest tends to select for different personalities in fish. For example, if your fishing gear is passive, like a stationary net, then you'll select against fish that approach the net, and these are usually more bold and curious and risk-taking because they're more likely to approach the net. So passive net fishing tends to select in favor of shy or timid fish that don't like to take risks. So commercial harvest tends to cause evolution of fish that are small, R-selected, and timid. This combination of traits, though, seems to be dysfunctional because if you're R-selected, you need to grow fast to maturity and reproduce quickly before you reach the size where you're harvested. And a timid personality seems like it wouldn't fit that life history very well. Another factor is the abundance of food in your environment. Generally, we assume that abundant food will tend to select for more R-selected or fast life histories, as we have a benign environment favoring faster reproduction, earlier maturation, which again favor a more bold personality. It makes no sense to be timid when food is abundant, food is to be had. But what if food is scarce? Well, we assume that harvest keeps populations at low density and assume that low density means absence of competition for food. Food is abundant if your population is at low density. At least we assume that, but that's not necessarily the case. Food can be scarce in any disturbed environment. So in this study, they wanted to look at these complicating factors. They wanted to see how selective harvest affects the two sexes differently and under abundant versus scarce food. And they wanted to know how personality evolves in addition to life history. And the study fish they used was a model species that is used for research because it's easy to keep in an aquarium. That's the Japanese rice fish. It's a popular pet fish in Japan. Cheap, easy to raise, easy to grow. So that's a basic, quick intro to the issues addressed and discussed in this paper. Very cool paper and an experiment that's easy to carry out on a small model fish that's easy to maintain and grow in the lab, like this Japanese rice fish. So enjoy the paper.